So as I go through this, again, I will pause, just kind of like I'm doing here. I'll pause as we're going through notes. I'll talk about some things like what you should use notes for and this and that, okay? At least especially early on. Okay? But we'll start here with these three undefined terms of geometry. Okay? So the first thing that we're going to start with, these are basics of geometry: point, line, and plane. These are called the building blocks of geometry. And again, there's three of them. It's point, line, and plane. We're going to talk about each of them, show how they're notated, and so that you can recognize them when they show up. Okay, so a point is an element that indicates position or location. It has no dimensions. Okay, so there's no length, no width, no depth or to it. It's just a position or location. Okay, when you name or example of a point is illustrated here. It's a dot with a label on it, a letter to label it. And when you name it, you're just going to name it as the letter. And you might see the word point in front of it, so point A could also be used, but that's notating a point. If you string an infinite number of points together in a straight arrangement, they form a line. Okay, so a line is going to have one dimension. That dimension is length. And it extends infinitely. Once again, it's that set of points are extending infinitely. So a line is made up of an infinite number of points arranged in a straight line. Okay, so here's the illustration for a line. You're going to see points labeled periodically throughout it. Okay, but even between points A and C, like technically there's an infinite number of points between them. The A, B, and C are just three chosen points to label on that line. Okay, when you name a line, you can pick any 2 points. So here we can take A and B with a line symbol on top. Doesn't matter the order, so we could have also called that BA. And you can do the same thing from each of the pairs of points. So you can say line AC or line CA, or you can say line BC or line CB. So this is probably the most common way that you'll see lines named. Just any 2 points and exactly 2 points on the line with a arrow symbol, the line symbol above it. For when you see a cursive lowercase letter, often it's going to be toward the middle of the alphabet. That's also a way to name the line, so we can call this line N. You might just see the letter, or you might see the word line N, just like the word point A. And the final way that you might see it, I don't have it labeled up here, but oftentimes you'll see a line labeled with a capital L and a subscripted number. So we could also call that line 1 as L1. L subscript 1. Right, if you take an infinite number of lines and you arrange them side to side infinitely, you form this flat surface that's called a plane. So the plane's going to have 2 dimensions. So it has the length of a line, but it also has the width to give it that second dimension. Planes are generally going to be represented by parallelograms like this, but they don't stop where the figure stops. It's impossible to actually draw an infinite shading for that plane. So whenever you see a plane, it's probably just going to look like the face of a box. But it does extend infinitely. So it'll be infinitely in each of these directions here. So it's a flat surface, and once again, it extends infinitely. When you name a plane's going to be named using any 3 points on the plane as long as they don't fall in a straight line. Okay, I'll kind of talk about that a little bit later, although it's not really emphasized here too much. But if 3 points fall in the same straight line, then there's an infinite number of planes that pass through them, so it wouldn't designate one individual plane. And for that reason, you need to have 3 points that don't fall in the same straight line. And then you'll just call it plane. So here, if I chose plane AB, I can't pick point C, right? Because point C falls in the same straight line as that. So any other point on the plane, which is that pink surface, could be used. So I could use D, I could use G, I could use K for my other point. I couldn't use E, I couldn't use F. J is a different representation, so J is not a point. So again, if I pick point G here, that would be one way to name it. And then if you do see a capital cursive, or it'll either be cursive or italicized letter, but it will be a capital letter, that's also a way that you can name a plane. So we can also call this plane J when you're naming it. To name a plane, you can use any 3 points that are not in the same straight line. Right. Let me talk really quickly before I assign these questions. Depending on which browser you use, the icon or the symbols like the line symbol may show up slightly different. And so what that looks like here is, if you are using Chrome, what will likely happen is that you will see line AB written where the line symbol trails it, and it's full size. So Chrome tends to, it doesn't read that line symbol being above the letters, the points. It'll be to the side of it. So just know if you are using Chrome that represents line AB. If you are using your iPad, what will likely happen is it would look like this. You're barely going to see that anything's even there. It's going to appear teeny tiny, but above the letters, and you'd have to zoom in with your iPad to even see that there's a symbol there. So just be careful or be aware if you're using your iPad or if you're using a Safari browser on a Mac, that you might have to zoom in to see what the symbols are. If you're using Mozilla Firefox, you generally see what it's supposed to be. That's the browser that that communicates the best with Canvas and MyOpenMath. And so that's why I recommend using that. Really, this is one of the only places where that happens. So there's another thing with Chrome and superscripted values, like a x squared. Sometimes the square doesn't really look like it's squared. It's like just slightly above, but full size. So Chrome sometimes has a few glitches, but the Mozilla Firefox browser is probably your best bet, especially early on here when you have this symbolic notation like this. All right, so what I want you to do is take a moment here and see if you can answer this first question, the top question. Find another name for line BF and line AD in that example, please. Okay, so if we name or label line BF, here's what we're talking about. What would be another name for that? So you can take B and D are 2 points that fall in that, so we can take those in either order, so BD or DB. What's another name for that? Okay, so you can also take the combination of DF in either order, so line DF or line FD, and then the last way is to take the original one, BF, and just reorder those points. Okay, and so those would be the three, or the remaining ways that you can name the line formed by those 3 points. Okay, so if we looked at the next example here, AD, if we look, here's line AD. And so if we're looking to identify what would be another possible name for that. Okay, so again, you can take a different combination of letters, AE in either order, or EA with a line symbol on top. ED, you can just take the other pair of points, ED in either order, so DE. And again, the last one, if we just take the original AD and flip it, we get DA as the other possible answer. So again, like pretty straightforward stuff. That's just being able to name a line. You only use 2 points, okay? Not 3, okay? And not 1. Okay, try the same thing for the planes down below. See. So if you just start going one by one and see, right? So if we start up above, plane A, B, and C, are A, B, and C in that plane? Yeah, but can you use it to name the plane? No. Okay, because they're in a straight line, right? And if you took this, like if you took those 3 points, I could draw another plane that passes through those points. Oops, I could draw another plane. I could draw another plane. Again, there's an infinite number of planes, like the sort of like the pages of a book, that would all pass through that same line, okay, as the binding of that book. And so you can't have points in the same straight line. So that one's a no. What about plane J? Yes, this is that case where you have the italicized or cursive letter. Hey, what about plane JGA? Is J a point? No, it's not a point. If it were a point, then that would work, but it's not a point, so that does not work. What about GK and B? GK and B, all 3 points are on the plane. None of them they're not in a same straight line, so yes, that will work. And then finally AG and B, AG and D. Once again, also yes, on the plane, not in the same straight line. So those would be the points, or those would be the names that would work, those 3. All right, any questions about the note-taking? Okay. So let's go to the next slide. Has to do with some of the elements that are formed from lines. Okay, so the segment and ray are portions of a line. And so when we look at that, a segment is going to be the portion of a line that falls between 2 endpoints. So here's the example of that. And when you look at these endpoints A and B and name this segment, you can put it in either order. But it only is formed with the endpoints of that segment. So the only ways to name this segment is segment AB or segment BA. Array is also a portion of a line. But this is the portion that extends from one endpoint and infinitely in the other direction. And once again, when you represent it, notice here my ray goes to the right. Here my ray points to the left. Notice the endpoints are colored slightly different, and the reason for that is to help designate that when you name a ray, you specifically have to name the endpoint first. Okay, so here this is ray AB. That's the only way to name that. The next one, even though it goes in this order, you cannot, you don't write it this way. So this is not the correct way to name this ray. Okay, you write it in the same order. The ray symbol is going to point to the right. You start with the end point of the ray, and then your second point is some point that the ray passes through. So ray BA is how you would name the ray on the bottom. And then finally, the last concept here is the relationship between 2 rays that form a straight line and share a common vertex or common endpoint, and that's opposite rays. And so if you have 2 rays that together form a straight line and they share that common endpoint, those would be considered opposite rays. So the rays that you're looking at here are from the point C through A and the point C through B. So those are the 2 rays that would be considered opposite rays here. All right, so go ahead and try answering that this single question here on this slide. And name all the rays with endpoint B, and then identify which of them would be considered opposite rays, please. So what would be one ray with endpoint B? Davis. Okay, so BD. So here's one. And that's how you would notate it. It's another. What would be another way to name that exact same ray? I could call it BD. I can also call it BF. Endpoint B passing through point F is this exact same ray. Okay, those two names refer to the exact same ray. Okay, what's another ray that I can name with endpoint B? B and C. So that's this one. And then I can also name B through A. And these are two different ones. But those are also the ones that are opposite rays, right? So BC and BA together form that straight line. So that would be your set of opposite rays. All right, questions on those elements. So point, line, plane, the three building blocks. Segment and ray are portions of a line. Opposite ray describes two rays that form a straight line. Okay, the next set of concepts are going to talk about relationships between points and some of the other elements. Okay, so points are either going to be, or sets of points are either going to be collinear or non-collinear. The word itself actually embeds the definition. Co or col means together or with. Line is a word that's inside the word itself. So this means that collinear points would be points that can be contained in the same straight line. So when you're looking at points that can be, it doesn't mean that the line is necessarily shown. Okay, so what that means is if I just gave you the set of points P and T, can you draw a line through points P and T? Yeah, it's there, or it's not written, or it's not included, but you can. The fact that you can means that those are collinear. And that would be true between any two given points anywhere in space. Okay, so any 2 points, no matter where they are, will always be considered a set of collinear points. Now, once you get to 3 points, now it can or can't be. Okay, so if I took point T and point X, what's the other point that I would have to choose that would be collinear, a set of 3 collinear points? Y. The only other point that falls on that same straight line would be Y. If I took T, X, and then any point other than Y, so either P or R, now that would be a set of non-collinear. So once again, the word is embedded, or the definition is embedded in the word. So non-collinear are going to be a set of points that cannot be contained in the same straight line. All right, so based on those definitions, go through on this next question over on the side, please. And you're just finding here, is the set of points that they give you collinear, non-collinear, or neither? Neither really is just a distractor. That's never going to be an answer. A set of points are either collinear or non-collinear. It can never be both, and it can never be neither. And so see if you can answer for those 3 sets of points, please. So you won't always have like just 3 collinear points. There might be more than that. So the best sort of strategy for this is to just start taking the points, take the first 2 and see is then the third one on the same line as the first 2. Okay? Or you can look, are there any that are collinear? So like this one, I might see X and Y are collinear, or on the line that's actually shown. Is P on that same line? No. So this would be a set of non-collinear points. T, P, and Y, so we have T and Y on the same line. Is P on that line as well? No, so non-collinear points. T, X, and Y, so T and X are on the same line. Y is also, so collinear. And then the final, if you say X and Y are on the same line, T is as well, and so also collinear. Now, let me give you just again a heads up about questions, because students do have do a pretty good job of trying to figure out patterns in the questions that are on your homework. So if you look at this and you think, okay, well, I'm going to have 2 collinear and 2 non-collinear. That's not necessarily the case. Questions like this will generally have like 3 or 4 versions. So one version would be 2 and 2, one version would be 3 and 1, the other version would be 3 and 1 in the other direction. Okay, it's possible it would be 4 and none, but probably not. So those, like for this question, there's probably those 3 different variations. And every time you try a similar question, you might get a random one of those. Okay, so don't just think because like a first time through it was 2 and 2, that's going to be the case. Actually, like just think through each one individually and see if you can figure it out. Okay. Right. The other relationship that exists between both points and just other geometric elements is whether they lie in the same plane. Okay. And so points can be coplanar. Once again, the definition is embedded in the word. Co means together or with in the same plane. So here, coplanar points are going to be points that can be contained in the same plane. Whereas non-coplanar are points that cannot be contained in the same plane. So when we look at sets of points, any 2 points are always considered coplanar because they're collinear anyway. Anything that falls in a line will fall in a plane. So all points on a line are coplanar to each other. So any 2 points that you find anywhere, even if it's not 2 points on a plane that's shown. So here if I took points K and J, those would still be coplanar points even though they don't fall on let me go back to, like those ends actually do fall on the same. So if I took O and J, O is on the shaded plane, J is on the unshaded plane, but they are coplanar because any 2 points in space are. Same is true for any 3 points. If you take any 3 points in space, you can form a triangle with them. So if we were to take J, O, and M, let's say, that triangle could then be extended infinitely in all directions and form a plane. So a triangle is a planar figure. So any 3 points in space, wherever they might fall, would also be considered coplanar. Once you get to 4 points or more, now you have to look carefully at the set and see. And once again, just like with the lines, I would find 3 points that fall on the same plane and then look to see is the 4th point on that same plane as well. So if I took M, N, and K, so M, N, and K, looking at those are all on the shaded plane, right? M, N, and K on the shaded plane. So if I want to find a set of coplanar points, I need to find another point that's on that shaded plane. What are my choices on that upper one? Coplanar points with M, N, and K would be L, what else? O, and P. So any of those 3 would be considered. So here if I just put O, that would be a set of coplanar points. Now if I took M, N, and K here, that shaded plane, and I wanted to find one more point that would make that set non-coplanar, what would be my 2 choices? J or Q. So it would have to be one of those 2, and now that's a set of non-coplanar points. All right, see if you can answer the question to the right for me, please. Or each of those sets. Identify, once again, and I'm going to use C and NC, C for coplanar, NC for non-coplanar. It gives you the option of neither, but once again, that's just a distractor. There's no chance that a set of points are neither. They're either going to be coplanar or non-coplanar. They're not both and not neither. So one of the things, and as you're finishing this, just again, anytime things come up that I think are important to know or useful to know, you don't have to do questions in order. Okay? So when you look at a question like this, you don't have to go from the top down. The same is going to be true when you're doing, especially quizzes or tests. You don't have to answer tests from 1, then 2, then 3. You can jump around. So like I always encourage you, do the questions that you're most confident in first, okay, then build up that confidence and then sort of use that to tackle the harder questions that you're not so sure about. The same is going to be true like inside of an individual question. So when you look at a question like this, the very first thing I'm going to do is I'm going to identify these two sets. So if I see any set of 2 points or any set of 3 points, I'm going to right away mark them as coplanar. So LQ, coplanar, JQM, coplanar. So that's the first thing I'm going to do. It doesn't matter whether they're all on the same, right? So if I look at J, Q, and M, those three don't fall on the same shaded or unshaded plane. However, it would be possible to create a triangle here, and that triangle is a plane itself, and so those would be coplanar points. And so I'm going to find those first, and now I'm going to go through the individual sets. So J, Q, K, and N. So if I look at J, Q, K, so those 3 points are on the unshaded plane. Is N on that as well? Now, be careful how you view the sort of the two-dimensional representations of three-dimensional space. Okay, so this is sort of like two planes forming an X or a T, right? Can you guys kind of see that? The unshaded plane is a little bit vertical, maybe, and then the shaded plane is a little bit horizontal. Okay, so that N is actually sticking out, or actually it's behind. The dashed lines generally mean that it falls behind something. So that N falls behind, okay, what you're looking at, and so that white plane is in front, the N falls behind. So N is actually not on that plane. So this would be a set of non-coplanar points. Okay, O, M, K, and J. So if I look at O, M, and K, those are all on the shaded plane. Is J on that same shaded plane? No. So that's a non-coplanar set of points. Again, all it takes is just the one to not be. Okay, looking at the next one, O, J, Q, and P. So if I go O, J is not on the same, so I'm going to take J, Q, and P. Those 3 points are on the unshaded plane. Is O on that same unshaded plane? No. And so the last one here, O, M, N, and Q. So O, M, and N are the shaded plane. Is Q on that shaded plane? No. So that's sort of the process I would use in working through a problem like that.